Today's discussion is going to focus on the Big Bang Theory as a possible explanation for the formation of the universe. We will end with a discussion about our solar system. These pictures are of distant galaxies and of a phenomenon called the Einstein cross, which will be described later. So, here we go. The beginning roughly occurred 10 to 20 billion years ago. However, best estimates put it around 13.7 billion years ago. Before that, though, there was nothing. There were no forces such as gravity, there was no time, there was no space. Then we have a singularity, which is thought to be the origin of the universe. Now, singularities are hypothesized to be the core of black holes. From this singularity, we had an appearance of a ball of mass. This ball of mass was extremely hot and extremely dense and contained hydrogen and a little helium, which are the two most abundant gases in the universe and the first two elements created after the Big Bang. Now, the Big Bang is one of a few theories that try to describe the transformation from nothingness to the existence of the universe. The most important thing to note is that it was an expansion, not explosion. Early, it was described as a flash or explosion, hence the term Big Bang. Today, we know that there was no explosion, there was and continues to be an expansion, which occurred in a trillionth of a second, the instant immediately after the Big Bang when the universe expanded with an incomprehensible speed. So instead, imagine a balloon expanding instead of popping. This is a much more accurate way to imagine the Big Bang because there was not a bang, just a large expansion. This was first proposed by George Lemaitre, who was a Belgian priest who first suggested the Big Bang theory in the 1920s. Now, you may be wondering what happened next. Well, the universe experienced slower expansion. This slower expansion started to take place only 1/millionth of a second after the Big Bang. Almost immediately, the universe experienced cooling and appearances of forces and particles. As the universe expands, it begins cooling immediately, and forces such as gravity come into being. Also created during the Big Bang are radiation in the forms of X-rays and radio waves. This is the first major era of the universe and happened 10,000 years after the Big Bang. During this time, most of the energy is in these forms of radiation. Today, these waves are throughout the universe and have been diluted, but they are still able to be measured. Soon, packets of gas formed, and eventually these packets of gas led to the formation of galaxies and planets. Stars also started to form when the universe was about 200 million years old. Turning now to evidence for the Big Bang, we start with background microwaves. In 1965, radio astronomers first discovered observable cosmic background radiation at a very cold temperature of 2.725 degrees Kelvin, which is about negative 454 degrees Fahrenheit outside the observable universe. These waves are what remains of the Big Bang. These are not the same waves that formed 10,000 years after the Big Bang as was mentioned above. Instead, these waves were formed 300,000 years after the Big Bang. Next, we know that the universe is still expanding. In 1929, Edwin Hubble observed that galaxies are moving away from us at speeds that are proportional to their distance. This is called Hubble's law. It also implies that the universe was once compacted. Next, we can be fairly certain that the universe had a beginning. After all, if the universe hadn't had a beginning, we wouldn't be talking about it today. Next, the theory of relativity is being proven. As to date, things like gravitational waves, gravitational lensing, and gravitational time dilation have all been proven. Gravitational waves suggest that the force of gravity travels in waves when the mass is accelerating. Gravitational lensing occurs when light from a distant object is bent around another object. The Einstein cross, depicted in the lower left-hand corner, is an example of this. It looks like four different objects when in fact it is four pictures of the same object. Now, gravitational time dilation suggests that the passage of time differs depending on the altitude of an object. The higher the object, the more gravitational potential it has, and thus time passes faster. This has been proven by the observation of atomic clocks at different altitudes. Lastly, we have the abundance of the lightest elements, again such as hydrogen and helium, excuse me, which were believed to be the first elements created by the Big Bang. Now, what exactly is the theory of relativity? Well, it was first published in 1915 by Albert Einstein. In general, the theory suggests and implies that if expanding, the universe must have had a beginning. This provides added support to Hubble's law and in turn to the Big Bang Theory itself. Next, nothing can travel faster than light, which is about 671 miles per hour. The speed of light also links space and time and appears in the famous equation E equals mc squared, where c is the speed of light. Next, we have the gravity distortion of space and time. Einstein theorized that gravity is the distortion of space and time, as is pictured here. As you can see, the green line represents a signal sent from the spacecraft to the Earth, and as it passes by a star, it becomes distorted and bent because of the gravity of the star. Now let's take a break for a second and go on our road trip. Some of the most interesting places in the universe. First, however, you need to know that the scale of the universe is based on light years. Now this table shows how long it would take a beam of light to travel between two objects. For example, it would take a beam of light 1.25 seconds to travel from the Earth to the Moon, and it would take 4.2 hours to travel from the Sun to the last planet in our solar system, or Neptune. Now let's look at the structure of the universe. First and foremost, the structure is a hierarchy, meaning that small things make up large things, and those make up larger things, and so on, as you'll see in a second. Next, we have voids. Now, voids are mass empty spaces in the universe, usually between galaxy clusters. The Sloan Great Wall is the largest known structure in the universe. It is composed of a sheet of galaxies that has a length of 500 million light years, a width of 200 million light years, and a thickness of only 15 million light years. Now we have dark matter. Now dark matter is believed to be the force that keeps galaxies bunched up together because some bunches of galaxies are moving much too fast to be able to be held together by the gravity of the galaxies alone. So some other force must be holding them together. Dark matter is also thought to be what accounts for 80% of the matter of the universe. Now going back to the hierarchy, we start with stars. Now best estimates guess that there are 3 to 7 times 10 to the 23rd stars in the universe, which make 80 billion galaxies, which can be grouped into clusters, which lead us to superclusters. Now, what we still don't know. Here I'm going to ask my students if they have any guesses or comments on what we still don't know about the universe. After discussion, I will start with where the singularity came from. If a singularity is the core of a black hole, then it can be argued that space existed before the Big Bang. However, in 1968 and 1973, British astrophysicists, one of whom was Stephen Hawking, declared that the singularity didn't appear in space, that instead space began in the singularity. So where did the singularity come from, and where is it now? We don't really know. What caused initial expansion? There have been many theories proposed, but none have been proven because it is very difficult to test these theories. What will happen? There are two prevalent theories on the future of the universe. One is the Big Rip. This proposes that dark matter will become denser and denser and will eventually tear apart all matter in the universe into elementary particles and radiation. The end state would be a singularity, and the process may repeat. There is also the theory of the Big Crunch, which says that eventually the universe will collapse in on itself and return to a singularity, which could then turn back into a Big Bang. It is possible that the universe has done this many times, resulting in an oscillatory universe where a big crunch marks the beginning of another Big Bang. Now that we have discussed the large overview of the universe, let's turn our direction to a place closer to home, or our solar system. Now our solar system contains the Sun, 8 planets, meteors, comets, and other space debris. Got gas. 4.56 billion years ago, the beginning of the creation of our solar system is hypothesized to have begun, with the explosion of a supernova. Scientists believe that a cloud of gas was disturbed by the explosion of a star. Supernovas can occur as a star dies, and this led to the collapse of a nebula. The force of the exploding supernova caused the pocket of gas to collapse, and eventually gravity pulled the gases and dust together to form a solar nebula. The cloud became more and more dense and hotter in the center as it collapsed, which eventually led to the formation of suns and planets. This is called the nebular hypothesis, which was first proposed by Emanuel Swedenborg, Immanuel Kant, and Pierre-Simon Laplace. Zooming in on the universe now, we start with the Sun. The formation of the Sun starts when gas from collapse of nebula concentrates. About 4.5 billion years ago, as a nebula collapsed and got hotter and hotter, hydrogen fusion occurred and a star was born. During this time, we have the conservation of angular momentum, which basically says that the nebula became hotter and denser as it spun, much like a figure skater rotates faster as they draw their arms in. Eventually, the gas heats up so much that we have the start of hydrogen nuclear fusion in the core. Eventually, though, the sun will run out of hydrogen and will become a white dwarf. After it has cast off its outer layers, it will become a white dwarf and will eventually become a black dwarf. Moving now to the planets, we start with the terrestrial planets, and they are located in the first half of the solar system and contain the planets Mercury, Venus, Earth, and Mars. Now, does anybody have a guess as to why we call these terrestrial planets? What separates them from the other planets? We call them terrestrial planets because they were formed toward the center of the gas cloud when gases condensed into a rocky material, and eventually these rock and metal debris came together and became larger and increased their gravitational pull, which eventually formed planet and moons. Now here we see, going from left to right, Mercury, Venus, Earth, Mars, and the dwarf planet Ceres. Their sizes are to scale. Moving now to the Jovian planets. The Jovian planets are so named because they are like Jupiter and include Jupiter, Saturn, Neptune, and Uranus. These planets were formed in the outer part of the gas cloud because it was cool enough to let the gases condense into ices, and the ices came together to form core-like objects which captured leftover gases. Now here we see the Jovian planets Jupiter, Saturn, Uranus, and Neptune against the Sun. Their sizes are also to scale. Now that we know the basic makeup of the solar system, let's look at the motion of the solar system relative to the galaxy. First of all, it is tilted 90 degrees. The plane of the solar system is tilted 90 degrees compared to the plane of the galaxy, which means we are bouncing through the galaxy. Because of the tilt, the solar system bounces up and down through the galactic plane. When the solar system is in the heart of the galactic plane, the chances of comets and meteors is significantly higher. This has been linked to mass extinctions such as the extinction of the dinosaurs on Earth. 217.215 kilometers per second is how fast the solar system is traveling around the galaxy, which means it takes 226 million years for the solar system to make a complete revolution around the galaxy. You are here. As most of you already know, the name of our galaxy is the Milky Way galaxy, which is a spiral arm galaxy, and our solar system is located on the Orion arm of the Milky Way galaxy. Now, the Milky Way galaxy, it's difficult to tell where it is exactly in the universe, but best guesses put it about 25,000 to 28,000 light years from the galactic center. It's difficult to tell where because of constant expansion of the universe, so instead we describe the universe as when. For example, we say the universe was formed 4.56 billion years ago instead of saying the universe is here, although scientists are working on sketches that show us where we are in the universe. So today we learned what the Big Bang is and how it explains the formation of the universe. We took a trip through the galaxy and our solar system, and we learned our place in the galaxy. And we also learned what may eventually happen to the universe and the galaxy for that matter. And I know I covered a lot of information in a very short time. Does anyone have any questions?